Okay, starting from this, our first lecture, that is about introduction to. In this lecture, we will discuss intro to fluid and fluid mechanics. Clear?
जी
Now, first we will define what is fluid. So we will define fluid. So any idea do you have about fluid? Anything which you can answer? What do you mean by fluid?
like a liquid,
Like
liquid.
a liquid. Okay. So generally, this is not a technical answer, but generally, people says that any substance that can that can let me write that can flow. Clear? This is known as fluid. Clear?
जी
This is general definition people use to define that any substance that can flow are known as fluid. But you can say that this is not a technical definition. We later on, after 3 or 4 5 minutes, I will also define fluid technically. But generally we can define substance that can flow. Clear? Now
जी
in this definition you can see there are two things. One is substance, and that second is flow. So what do you mean by substance? Substance is substance can be defined as anything. There are certain properties of substance. How do you define substance? So anything that has finite mass. Clear? Means that that it has certain mass. The second thing is that it occupy space. Clear? And the third one is that is tangible. These are known as substance. So those substance which can flow are known as fluid. Now what do
Wait,
you mean? G.
tangible? What do you mean by tangible? So
Tangible
finite.
means that existable. You can search it on Google as well. Clear? By tangible means that easily available, or you can say that it is in physical form.
Okay.
Clear?
जी
Okay. So substance is actually the example for examples are matters. Matters. Clear? Now in matters, all matters are substance. So matters can be classified as solids. Clear?
जी
The second one, it can be liquid, and third one, it can be gas. Clear?
जी
So you can see that in solid, when you go on microscopic level, you can see the solids are close, the molecules of solids are closely packed with each other. Clear?
जी
And in material science you will study that intermolecular force or bonding between these molecules are very strong as compared to liquid. In liquid, the molecules are a little far away from each other, so
जी
the bonding between them is weak as compared to this is ionic bond. Clear? And that may be
covalent.
covalent or some weaker bond. Clear?
जी
And in gases the molecules are too much away from each other. Clear?
जी
So the bonding is very weak as compared to
हाँ
solid.
जी
Weak. Weak. Okay, as compared to solid. So what we say that this liquid and gases, they are lies under the category of fluid. Clear?
जी
So any substance that can flow is known as fluid. Now what does this flow means? We have defined substance, that substance is anything which have finite mass, occupies space, and tangible. Now we will define this flow, that what do you mean by flow? Do you have any idea?
a movement, maybe velocity. So
Okay, so in this ionic molecules, you can see these molecules are very close to each other. The gap between them is negligible. So
जी
this molecule, there is no freedom for these molecules to move. Clear? So
जी
they are closely tied. Now as compared to gas or liquid, these molecules are far away from each other, and the bonding between them is also weak. So what they are free to move here and there. Clear?
clear.
So you can see that each particle can change its position relative to each other. So if this is diagram with respect to T, so you can see these molecules are free to move, so their relative position change. So we define flow can be defined as relative change of change of positions of particle with respect to time. WRT with respect to time. So with respect to time, this molecule is now here. Maybe at certain time it may go there, it may go there, it may go there, it may go there. So with respect to each other, they are changing its position. Clear? So
जी
it means they are flowing. While in in solids, these particles are closely packed with each other and they are not able to move freely. So that's why solid cannot flow and liquid or
जी
gas which lies under the category of fluid they can flow. Clear?
जी, clear.
So in short we can define generally that fluids are the substance that can flow.
Okay.
Okay, so summary is that fluid having mass. Okay, there are some certain property that fluid have mass, they occupy the shape of the container, and fluid do not have any certain shape. You can see water do not have any shape. When you
जी
put it in any jar, glass, or any bottle, it gets the shape of that jar, bottle, or glass. So
जी,
it do not have any specific shape and occupy the same shape in which it is poured, and it can also flow under the weight. So these are the certain property. Now we will technically define what is fluid. Technically we can define fluid. I will write this definition and then I will explain it. Okay?
okay.
Okay. Fluid can be defined as be defined as substance or anything which continuously which continuously deforms under the action of shear force, under action of shear force. And the condition is that no matter how small the shear force, no matter how small is shear force. Okay, now what does it mean? That you can see that, for example, if we have solid body, clear,
जी
that is on a surface, and when you apply a shear force F, clear, so this shape will deform like this. You have studied in solid
जी
mechanics. Clear? So under elastic limit, this deformation occur, and when this deformation or internal resistance offered by this material to external force become equal, so this deformation will stop. Clear? And you know that
जी
this is shear strain. Clear?
जी
Now when you remove this force, so it will come back to its original position.
जी
Clear? This is for solid. Now if you have liquid like this, for example, this is liquid and this is at rest, and if you apply force, this is the boundary. Clear? So when you apply force, it will happen that due to this shear force, it will also deform like the solid. Clear?
okay.
But when you remove this force, it will not come back to its original position. Instead, it will further move. This upper layer will these all these layer will move with respect to each other. Clear? So
Clear.
there will be flow. So what does it mean? It means that any substance or thing that
Continuously.
continuously deform under the action of shear force, no matter how small shear force. If they You can see, if you have a glass of water, clear, and
जी
there is water in this glass, so when you tilt that glass in this direction, so what happened? The water also tilt back. Clear?
But wait, sir, if you tilt the cup and then you put it back into original position, the water's gonna come back to the original.
No, when you bring it to original shape, the water still will move, shake, and after some time it will come back to its original position. And what if you pour this water on any surface, so it will flow, clear,
G.
on that surface. Why this happen? Because there is a continuous deformation between different layers, clear.
G.
And now you will ask that after some time this water become steady. So what does it mean? It means that the friction between different layers become overcome their movement, so it stops,
G.
clear.
Clear.
So technically we can define that fluid is any substance that continuously deform under the
Under
action of
shear
shear
force.
force, no matter how small the shear force is. This is the example. And if you remove this force, so it will not, liquid will not come
Oh,
back to its original position.
G. It's gonna continuously deform.
It will continuously deform. That is
Okay.
we know, we call it as um, fluid,
G.
clear. Okay,
And this also
now
happens with gas
G, yes, this is for the gas.
as well.
This is
Okay.
when you apply any, you cannot apply forces. If you have piston, you have gas in a cylinder and piston, and you want to press it. So what will happen? You are going to apply forces on that gases or molecule,
But that
and
wouldn't be shear force, sir, right?
that will be not shear force again. But you can say if you have a container that contain gases, clear.
G.
So the gas molecules are the intermolecular distance between the gases are very large, clear. So they are freely to move. So again, in that condition, we can say that the relative position of each molecule with respect to each other is changing with the time. So it is also flowing.
Continuous. G.
So
Continuous.
continuously deforming, clear, because their positions
Clear.
are continuously changing with respect to time. That is why we say that gas also comes under the category of fluid.
G. This is clear.
Okay. Okay, now we define mechanics. What is mechanics? Can you explain what is mechanics?
Mechanics is like
You have studied solid mechanics, and
the
again
moving.
you will
That's
study
something
solid mechanics.
movement.
But in this, the word what mechanics, what does it mean?
Like movement.
No. Okay, the in mechanics can be defined as the study of effect of forces on a body, clear. So for
Okay.
example, this is body, this is a body, clear. And you are going to apply force on that body. Now in mechanics we study what are the effects of this force on this body. What are the effects in your opinion? What will be the effect of this force on the body?
So if there's a shear force going to the right, what will happen to the body?
Okay,
So then
okay,
the body is
okay, let's forget about shear force. This is body of mass m, and when you apply a force on that, clear.
G.
So due to this force, what happened to this body?
So if it's more than the force of friction, then the body's going to move to the right.
Yes. So the body will displace. Displacement we usually denote by S. Clear?
G.
So if due to this displacement there will be velocity, this object will move with certain velocity, and obviously we will have acceleration as well. Clear?
G.
So this is the force, and these are the effect of due to this force on that body. So
G.
in statics you have studied that in statics what you have studied, that body was under the rest and different forces were applied on that, and you want to study the effect of these forces on that body, that what will be the change in length of this body, clear,
G.
and their movements. So in mechanics is in shortcut, mechanics can be defined as the study of effect of forces on body. So
Okay.
that when you apply a force on body, what will be the effect of that forces on body?
G.
This is what we call mechanics. Clear?
Clear.
Now in mechanics, when you study mechanics, so mechanics, there are two type of mechanics. Number one is statics, and number two is
Dynamics.
dynamics. Dynamics, statics is the study of body at rest. Body at
Rest.
rest. When the body is rest and you apply the forces on that, so what are its effect? So that is studied in this statics. Clear?
G. Clear.
But when the body is at motion and there are forces applied on that body, so what will be the behavior or what will be the effect of that force on a body moving with certain velocity, speed, or with certain displacement? So
G.
that study comes under the category of dynamics. We
Dynamics.
have studied statics, and recently, as per your statement, that you have given the exam of dynamics. Clear?
G.
So in dynamics, all the body will be moving, were moving, and the forces that are acting on moving body, and you are going to find the effect of that forces on moving body.
G.
Clear? Now we will come to the fluid mechanics. That what is fluid mechanics? So we will then summarize these things. Okay.
Okay.
So now you can you repeat what is mechanics?
So mechanics is the study of the effects on a body. The
The
forces.
study of force and its effect on any body is known as mechanics.
G.
Clear? Now we will define fluid mechanics is defined as the study of effect of forces on fluid. Study
Study of
of
effects.
effects of fluid effect of study of
Forces.
effect of forces on fluid. Forces on fluid, that when there is a fluid and you applied force, so what will be the effect of that force on fluid? This is what we call fluid mechanics. I will repeat, the effect of forces on fluid is studied under the
Fluid
fluid
mechanics.
mechanics.
G.
Again, fluid mechanics are of two type. Fluid
Statics
mechanics,
and dynamics.
no fluid statics. Oh yes, fluid statics. Clear?
G.
And the second one is fluid dynamic.
Dynamics. G.
Clear? Dynamics. Now when the fluid is at rest and different forces are applied on it, so what will be the behavior of that fluid? That will be studied under the category of fluid statics. Clear? And the when fluid is in motion and
Dynamics.
forces are applied or forces are acting on that fluid, so what will be the behavior of fluid? That will be studied in fluid dynamics.
G.
So in our whole this course of fluid mechanics, we will study some portion of fluid statics and in some portion of fluid
Dynamics.
dynamics. Clear?
Clear.
Okay. Let's proceed further.
Okay.
Now, up till now, if you have any question, you can ask.
No, sorry, this is very clear.
Okay. Now we will study another topic, that there are there are two approaches two approaches to study fluid mechanics. Here,
Mm.
FM. I will write shortcut FM. The one is macroscopic approach. Clear?
G.
Macroscopic approach. And the second one is microscopic approach.
G.
Clear? So, what is difference between in these two? Can you uh, can you tell me this if you
So
have any idea?
microscopic approach. So microscopic, the second one, we're gonna look at the molecular structure of the fluid. So we're gonna look at the
Yes,
molecules.
yes,
Macroscopic, we're gonna look at the entire liquid or the entire gas and the
yes. Very good, very good. So, in microscopic approach, you are going down toward microscopic level. Clear? And what you do is that you take individual molecule, individual
molecule.
molecule, for analysis, for
analysis.
analysis. And then you take average of average behavior of average behavior of these molecules, of all molecules. Clear? To
G.
study the behavior of fluid. Clear?
Okay.
And based on different molecules and their every value, we study their behavior. While in macroscopic instant of molecular level, you are taking study the overall
Behavior.
behavior of fluid,
G.
which you have answered me. Okay. Okay. So you might have heard about classical fluid mechanics. That is very old concepts of fluid mechanics. And you see that many scientists came, like Archimedes, Bernoulli, and many other scientists came, and they worked on fluid mechanics theories and built built up the new concept. And currently you can see that the current or modern fluid mechanics consist of many sophisticated techniques that is built by these scientists. And one of the example of this contribution is, you have heard about CFD. Do you
No,
have you heard about computational CF fluid dynamics?
no, sir.
Okay, so let me tell you something very briefly about this. You have seen these car structures. Clear? I am not here good in drawings because I'm
Uh,
drawing it very quickly. So our aeroplane structures. Clear?
G.
So their design is purely based on this uh, theory of fluid mechanics. Clear? So what you can see, when they move in air or in atmosphere, the air force are acting on these structures. Clear?
G.
So in the main aim of mechanical engineer is, in the subject of fluid mechanics, is that they are trying to reduce the resistance or this drag force on that object. Clear? So
G.
all these shapes you are just looking, that in modern car, early the car design was very simple, like
G.
rectangle shape. So what is the effect that the drag force or the air force acting on it is large? Clear? So
G.
it affects the performance of that car in term of more usage of fuel. But nowadays you see the modern cars having very good shapes and curves on that. So these curves are actually the result of this computational fluid dynamics that shows what will be the behavior if you have any shape. For example, if you have aerofoil like that or wind turbines. Clear?
G.
So what will be the behavior of air? So the design should be in such a way that maximum lift force or thrust force are applied on that with minimum resistance in motion. Clear?
So wait, sir, CFD relates to the shape of uh the car or the plane, or does it only do it with the fuel? Like, what's the
It
best way for the
actually, your
control?
shape defines the performance of aeroplane, car, and many other
G.
things. Clear? So in order to increase the efficiency of your structure or smooth fluid flow, we use
G.
CFD. I
Okay.
will prefer you to go to Google. Clear?
G.
And just write computational fluid dynamics.
Yes.
Clear? And you will get a certain idea. You can take 2 or 3 minutes on Google. So you will be having a clear idea. Otherwise, I will look in on YouTube and will give you a very short video to
G.
know about what is CFD.
Okay.
Clear?
Clear.
Okay. Now what we discuss is macroscopic level and microscopic level. Now how you will know which approach should be applied? Do you have any idea about this?
When to apply which one?
Yes, where it to apply and which one will be good to apply.
It depends on what's given, maybe, like what you want to figure out.
Okay. So let me explain before deciding this, that which technique is much better or which one is to apply. Let me explain something. Okay.
Okay.
Okay. So in macroscopic, while studying macroscopic approach, we have certain assumption. So what is that assumption? I will write it first. That the assumption used in macroscopic approach is that the size of molecule, the size of molecule is greater as compared to distance. You can say distance, or you can say gap, or you can say void between them. Clear? So what does it mean? It means that if this is the size of molecule, clear? So this gap, you can see this gap,
So distance, size
this
of
gap,
molecule
this
is
red, this gap. For example,
G.
there is another molecule, this is another molecule, this is another molecule, clear? Molecule. So you can see these are the gaps, clear?
G. So they're smaller than
Between,
the molecule.
it's smaller than the molecular size. So
Okay.
what does it means? That when the size of molecule is greater than size, distance gap or wide between the molecule, and this means that this leads to uniform distribution of the mass. Clear?
G.
Okay. Distribution of mass. And remember that this uniform distribution of mass is also known as continuum. Clear?
Okay.
Whenever I will say continuum, so you must know that the distribution of mass is equal.
Okay.
Clear? Okay. Now, if the molecules are very small and the gaps are larger, clear? So what happened?
Microscopic approach.
Microscopic, and also now here the gaps are larger as compared to size. So distribute, there is no uniform distribution of mass.
So size of molecules are different?
Yes, the size of molecules is smaller as compared to the gap between them. How you will know that? In a while we will discuss that also, but this is case number 1 and this is case number 2. In first case, you assume that the size of molecule is greater than the gap between them. Clear?
G.
So this leads to uniform distribution of mass, which is also known as continuum. Clear?
Okay.
The second case is that if the size of molecule is small as compared to distance between them, then in that condition there will be no uniform distribution of mass.
Okay.
Clear?
Clear.
And what will happen here?
If if there's
Okay. Okay,
greater
so let me explain. If there is a uniform distribution of mass, so in that case, if you take, if you want to study the behavior, study behavior. So how you will study the behavior? For that you will need certain equations, just like Bernoulli's equation or continuity equation or any other equation. These equations shows you the behavior of fluid. Clear?
G.
So in order to study the behavior, you need equation, and definitely by using this equation, you will take integrals, you will take
Enter
derivatives,
G.
clear? And you have studied calculus as well. So
G.
if your function is continuous, if your
G.
functions are continuous, so you can apply easily integral and derivative.
G.
Clear? That can be easily solved. But if your distribution of mass is not continuous, so that equations you will obtain will be difficult to handle.
You'll
Why?
have to have multiple
Because this will be discontinuous function.
G.
Clear? And you will apply integral and derivative, and that will be too much complex and difficult to solve.
G.
So that's why we usually prefer to study the macroscopic approach. Clear?
Clear.
Now, how you will check whether the case is macroscopic or microscopic? Clear? So for that, I will use another term. That that term is known as Knudsen number. Clear?
That's in.
Knudsen number, that is represented as Kn. Clear? This Kn will define whether this is continuum or this is non-distribution of mass will lead toward macroscopic. Clear?
So if it's so depending on wait, sir, I don't understand the K in numbers. So
I will
but
explain Kn number. What is Kn number? But remember that if your distribution of mass is uniform, so
then
it
it's
means that that
macroscopic.
is macroscopic approach or continuum. Okay.
G.
But if your distribution is mass is not equal, so that means that you are going on microscopic
Macro.
level.
G.
Clear?
And you use Knudsen's number to solve to figure
to
out if
to
it's
to
uniform.
figure out whether this is macroscopic, this study is macroscopic or microscopic.
Okay.
Clear? So what is Knudsen number? Let me explain that. So Knudsen number Kn or Ku, I think Kn or Ku, something like that. I don't remember, but this is Kn or Ku. I will tell you whether it is Kn or Ku. Clear?
Okay.
So this Knudsen number is the ratio of. Let me write first, and then I will explain. Mean free path divided by characteristic length. Characteristic length. Now, what is characteristic length? For example, if you have fluid,
Wait,
fluid is like this.
wait, so Kn is equal to Ku over Kn?
No, no, no. It is Ku or Kn.
Oh, okay, okay.
I don't remember whether Kn or Ku.
Okay, okay.
It is simple representation of Knudsen number.
See.
Clear?
So that's mean free path over
Or characteristic length. For example, there is a fluid. Clear? That is flowing. Clear? And if you want to emphasize on certain portion of, or if you want to observe over this length,
G.
you are focusing fluid over this length. So this length will be known as characteristic
Characteristic.
length. Clear?
Clear.
Now, what is mean free path? So in fluid, we know that the the molecules are a little bit far away from each other, and they are free to move either in fluid or in gases. Clear?
G.
So this molecules when comes toward this and hit this. Clear? This is one hit. Maybe these molecules come toward this and they hit this. Clear?
So how
So
many
all
hits?
matters. Ji,
So wait, it's the amount of hits?
it might hits. Clear?
Uh, G.
Because these molecules randomly hit each other.
G.
Why? Because there is no strong bond in this fluid, and they are
G.
free to move. They are free to travel, and they collide with each other. So you can see here I have shown you two consecutive collision. This comes with and collide with this. This come and collide with this.
Okay.
Clear? So the distance traveled between two consecutive uh, mean collision is mean free path. Now you can see this distance. Let me choose another color. This is the one collision and this is another collision. So this distance is known as mean free path. This is the distance distance travel between two consecutive collision is known as mean free path. Clear?
G.
And this mean free path is represented by lambda, and this characteristic length is represented by L. So Knudsen number Ku or Kn is equal to lambda divided by L. What is lambda? Lambda is mean free path, and L
G.
is characteristic length, the length over which you are going to analyze the fluid.
G.
Clear?
Clear.
Let me write what is characteristic length? So characteristic length is defined as length length of fluid between or length of fluid, cut this between which we in which we analyze,
Observe.
in which we observe or analyze this fluid. Clear?
G.
Okay. Now, if it is clear till now, now we will define the criteria.
Okay.
Okay. So the first criteria is that if your, later on we will see, if your Ku is Knudsen number. Actually, this is Ku. Okay.
It's KU.
Okay. Yes, a Ku. If your Knudsen number, after putting the value, if you have mean free path value and characteristic length, and you put it, and if you get 0.01, clear?
G.
So this means that
Continuous.
continuous or continuum. In shortcut, I will write continuum. Continuum mean continuous distribution of mass.
G.
Clear?
Because length. Because then the length is or G. Because then
Yes.
that mean free path is smaller.
Yes. Free path is smaller and length is larger.
Oh,
So
G.
it means that the gap between the molecule is very small.
G.
Clear? So which means that this is continuous or continuous distribution of mass.
G.
Okay. So fluid volume as compared to gap between the molecule is negligible in dimension. So we neglect it and consider as continuous distribution of masses.
G.
Clear?
Clear.
Okay. Okay. If there are significant gaps, then property like density, specific volume become discontinuous. This is the same thing that we have discussed, that if there is gap is larger, so it will affect the some properties like density, mass, specific volume, because this will give you discontinuous distribution of mass.
G.
Okay. Now again, the second criteria for that is that if Ku is greater than 0.01 and less than 10. Clear?
Oh,
So this is what we call, in this is slip flow. Now what is slip flow and what will happen? So let me explain these two things. Okay. So in first criteria, I am talking about Ku is less than 0.1.
one.
So you can see this is the boundary and this is the fluid flowing. Clear?
G.
Okay. So when your fluid is flowing, clear, and Ku is less than 0.01. So the molecule that is attached with this boundary or this surface, clear,
Clear.
its velocity is will be equal to 0. Clear?
No. Wait.
Okay.
I,
You can say if you put fluid in any container, clear, there will be molecules, some of molecule that will be attached with this
G.
surface and some will be above this surface. Clear?
G.
So for example, in river the water is flowing in this direction. Clear?
G.
So the level of water that is attached with this base, clear, I am
Will be
talking about that molecule. Clear?
okay.
That
That
is
will be
bounded to
0.
that surface. Clear? So their velocity will be equal to 0.
And that's on the macroscopic.
Oh, and that is under the condition when Ku is less than 0.01, then the molecule that is attached at the surface will be having velocity 0, and this is known as no slip condition. No
Slip.
slip condition. It means that the molecule that is attached with this boundary is not slipping. Its velocity is 0, but the molecule that is above this level will move with certain velocity
Okay.
because they are free to move. and this molecule is attached with this surface.
Yeah.
Clear?
Okay.
This is the condition when Ku is less than
0, 1.
0.01. Now the same scenario is that if you have same fluid moving in this direction. Clear? And when your Ku is greater than 0.1 and is less than 10. Clear?
G
So what will happen is that in that scenario, your molecule that is on this surface
is
will
moved.
have will not have velocity is equal to 0. What does it mean? It means that it is slipping on this surface.
G.
Clear? And this condition is known as slip flow.
And sir, will this be discontinuous when it's slip flow?
Okay, this will be again Ku is greater than it will also it will come under the category of continuous because
Oh,
K is greater than 0.01 and less than 10. Clear?
okay. So one
Okay.
condition 1 and 2 are both continuous.
Yes. Till now, what I have learned that they are both continuous. Clear?
Okay.
And for slip condition, you can also define as for no slip condition, Knudsen number should be less than 0.01. Clear?
G
And what is no slip condition? That the molecule that are attached to the surface are having velocity
0.
0. And when your Knudsen number is greater than 0.01 and less than 10, so in that condition, the molecule that is attached to the surface will not have zero velocity. It will have certain velocity. So it means that there is a slippage between this molecule and the surface toward to which it is attached.
G.
That is known as slip flow. Clear?
Okay. This is clear.
Okay. Now the third and the last criteria is that what if your Knudsen number is greater than 10? Clear?
G.
So that is known as free flow, free molecular flow. Clear?
And this would be discontinuous.
This will be the discontinuous. Clear?
Uh,
Or that will be under the category of microscopic approach, study of the fluid.
G.
Clear? So by using these criteria of Knudsen number, which define whether we should go towards macroscopic study or microscopic study.
Okay. And
Clear?
when it's free flowing molecular flow, sir, each molecule has its own velocity.
Yes, each molecule will have its own velocity and it will move. And what
Okay.
does it mean Ku is greater than 10? It means that uh, free path is large as compared to the gap.
Wait,
You can
sir,
see,
whenever we solve for Knudsen number, right? The
yes.
characteristic length will always stay the same, or will it be different? And will the mean
Okay.
path be
For
different?
any study, you have to take a constant length.
So this will L will always be constant.
Yes. If you
Uh,
change, then definitely for a specific length for observation, you have to fix that length.
So if we have a very small mean free path, then we
Okay.
know that okay, this is going to be continuous or macroscopic. If there's a very big uh, distance between the consecutive collision, then we know it's going to be free flowing just because the gaps or distance between each molecule is very big.
Yes, you can see that Knudsen number is lambda over L. Lambda is free mean path and length is
G,
characteristic length. So if this value is greater than 10, what does it mean? It means that
free
this
flowing. G,
numerator is larger and denominator is smaller.
constant, small g.
So it means that the distance between the molecule, this distance, this this distance between the molecule is larger. So it means that the distance between the molecule is larger. So it means non-distribution, non-discontinuous equations are non-distribution of
Non
masses.
G.
So that's come under the category of microscopic approach.
Okay. This is
Clear?
clear.
Okay. And the last topic that which we are going to cover for today is type of forces in fluid. Clear?
Okay.
Okay. So types of forces in fluid. So we have two type of forces. The first one is surface force. Clear? And the second one is body force. Can you differentiate between these two?
So surface force is going to be force between molecule and the uh, surface or like the glass, and then body force will be. I was just thinking
since
body
since
force is
since we are talking about
molecule.
fluids, so you have to be you have to restrain yourself on fluids. Okay, for example, if there is a fluid, clear,
G.
so you can see there is a fluid in a container. Clear, this fluid
G.
is at rest. You can see there are gases in atmosphere.
G.
Clear, that apply this for our atmospheric pressure that is applied over this surface.
Okay.
Clear.
Clear.
So these are known as surface forces that is acting on the surface. External force that is acting on the surface of fluid.
Okay.
Clear? It can be external or it can be internal. Later on, you will study that due to there is a term. Okay, what is that term? I just forget. There is a way due to which internal forces also tend to 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 attract these surfaces.
Like the air bubbles or
Surface tension.
surface. Okay.
Due to surface tension, I we will later on study what is surface tension in detail. But due to this surface tension, these molecules also attract each other, which tends to decrease the level. Clear? So these are the surface forces that is applied on the surface of fluid. Clear?
So, so surface forces are atmospheric force.
Yes, atmospheric forces are any other force that acts, external force that acts on the surface. For example, if you have gas and if piston cylinder and you are hitting or you are compressing that gas, so these are the external forces and that they are known as surface forces.
Okay.
And what is body force? So body force means that the force that is generated due to the mass of due to mass or weight of the fluid.
Okay.
These are also known as gravitational
Forces.
gravitational forces. So forces that act on the surface of fluid, whether external force or internal force, are called surface force. Clear?
G.
While the force generated due to mass of fluid throughout its volume is called
Body force.
body force or gravitational force. Example of body force is
Weight.
weight of that object that is due to gravitational force.
G.
Clear?
Clear.
While surrounding the atmosphere, the external pressure or force on surface are known as surface forces.
G.
I have explained regarding it as fluid mechanics. In statics, you can see when one body interact with each other. So they are known as, or this force act on this surface. So these are surface forces. And
Wait,
for
sir,
example, G,
when when it says surface tension, doesn't mean it's going to elongate.
no, this is not that tension. This is something else.
Okay.
Okay, let me let me show you surface tension, a little glimpse about that. Surface, surface tension in fluid. Actually, this course is not very easy course. Clear?
This one is harder than the solid mechanics,
Yes,
sir.
this is also harder than solid mechanics. So you can see that here you can see these are the molecule. I am not able to write on anything, but you can see these molecules. This the lower molecules attracts the another one or hit another one. Clear? So as a result, this upper surface shrinks.
Okay.
This is what we call
Surface.
surface tension. Clear?
Clear.
Later on, I will explain it in detail.
Okay.
Okay. So again, this is not that tension that we studied in
Solid
mechanics
mechanics.
of material. Clear?
G.
So, what can you define what is mass?
Mass.
Yes. What? How you define mass?
It's the amount. Hey,
Mass is
quantity
defined as quantity of matter
of an object.
present in a body or object
G.
is known as mass. Clear? Clear? And what is weight?
It's amount of gravitational force on.
Weight is
Right.
weight is defined as the force that this quantity of mass or quantity of matter produced due to gravitational effect.
G.
Clear? Force that is exerted by this mass due to gravity is known as weight. Now, for example, if you have 1 kg weight, clear? So mass is a constant quantity. You can see that due to law of conservation of mass, we say that mass can neither be created nor destroyed, but it can be changed from one form to
Another.
another
G.
form. Clear? So if you have 1 kg mass and that is on earth, clear? It will be same 1 kg mass on moon.
G.
Clear? But weight of 1 kg mass on earth will be
Different.
weight on
Lighter.
earth
It's gonna
will
be
be
lighter
greater
on.
than weight on moon. That
G.
will be different. Why?
G.
Because due to the gravitational effect.
G.
Clear?
G. So wait, I had a question. It's
Yes.
kind of related. How come when people say, "What is your weight?" People say, "Oh, I weigh like 70 kg or 75 kg or 80 kg or something like that."
This is actually mass.
But when someone asks you, "What is your weight?" Some people
Okay.
give it when people give it indicate.
Okay.
So what
You
weight
can
do you?
see, have you seen kg and kgf? Kg and what is different between kg and kgf?
One is force, maybe.
One is force, this is force. Clear? And this is mass.
So there's difference between KGF and
Yes,
KG.
you can check it. Google. Let me check it also. 1 kg is equal to how much kgf?
So, sir,
1.
when we normally talk about how many kgs you weigh, you talk about kg. But right now we're doing things in KGF.
Actually, when you are going to measure the quantity of matter, that will be
G.
in kg. Clear? And
G.
when you are going to define 1 kg force, so
KGF.
that will be kgf. Clear?
Okay.
And I think there will be a relationship between both two. Weight of 1 kg is 9.8 newton. Clear? And again, you can search it. I think you can search it. 1 kg is equal to how much kg
Nine
force?
point
The
eight.
kilogram force or kilo pound.
So it's just 9.81. So one
Okay.
times gravity.
9.81. Again,
Okay.
it's clear.
Clear.
Okay, so you have to multiply 1 with g, acceleration due to gravity. So that will be kg force.
So if you divide your weight by 9.8, then you can get your KGF.
But that will be the force that your body is exerting. For example, if you are standing on a car,
G.
on the roof of car, now your whole mass is exerting a force on that roof of the car. Clear?
G.
if your
Clear.
force if your force become exceed then the elastic limit of that roof, clear, so it will create dent in that.
G.
Clear? But if your force is not enough to produce any deformation, so it means that the material is having more stronger, having more yield stress or resistance stress as compared to your force.
Okay.
So it's very simple. Do not confuse yourself. Weight, mass is the quantity of matter. Clear?
Okay.
And weight is the force with which Earth attract a body towards
Quantity.
its center.
Yeah.
Clear?
Clear.
Any other question?
No, sir.
So in this way, I will conclude. I will uh, finish this our first lecture, and believe me, for explaining these some few things, I took 2 or 3 days. I checked many books, but from here and there, I collected this thing and got this concept. Clear?
But sir, I really like the lecture, sir. This is very interesting to me. I actually am interested in the fluid mechanics now.
Actually,
You made it a very nice lecture. I actually liked it a lot.